Please wait, children. One minute. I'm sharing. I'm sharing board. Please wait.
Ma'am,
Huh.
ma'am, from morning Shri is not unable to open NCB it seems, ma'am.
Oh, there is a technical issue.
Yes, ma'am. In maths class also, is unable to join, ma'am.
Mhm. Okay, that's fine then.
Okay, ma'am.
So, okay, children, are you able to see board now? It's
Yes,
fine,
ma'am.
Yes, ma'am.
right?
Yeah, ma'am.
Power.
Okay, yesterday we are discussing about law of
Kinetic energy and
conservation of
ritual
Energy.
energy, right?
energy.
Yes.
Energy.
So now we will learn some other interesting topic, that is power. What is power, children? Did you ever hear a word called as power
Yes, ma'am.
in your daily conversation, or sometimes when you talk with your friends, or with your neighborings, or any other common conversations, we will be coming across hearing a word called as power. So what is power?
Ma'am, can I?
Vishnu?
Ma'am, comparing the energy with the ratio of time, ma'am.
Energy with the ratio of time. Okay,
Yes, ma'am.
somebody please try in more different senses. We have multiple ways which you can explain or express yourself what you feel
Ma'am,
about
can I?
power. Please.
Ma'am, rate of doing work or the rate of which energy is transferred
You have
or
to explain
transformed to others.
also. I mean, when you code it, no, whatever the definition you are telling, that's really fine. Okay, correct. But please explain me. Can you give me one example for it? Can you give me one example for it? Somebody has told me rate of doing work. That's fine. But
Ma'am, can I give an example and explain, ma'am?
please, Vishnu.
Ma'am, example, two cyclists are there, ma'am. Two
Okay.
bicyclists.
Okay.
Both are bicycling in a road, ma'am, in a straight road. A time,
Okay.
particular time, 1 hour is given, ma'am. Who will
Okay.
cover the maximum distance? They have the more power, ma'am.
Okay. So you're talking about maximum distance. Okay. So those who cover the maximum distance in particular time, so they have more power, isn't
Yes,
it?
ma'am.
Okay.
Yes, ma'am.
So one more example also I can give you in this regard to understand more clearly. For example, two friends are there. One we will call it as, let us say, A, and another one is B. These are our A and B are two friends. Okay, for example, okay, they are walking. Let us say they are walking on a road. They are walking on a road. Okay, so the road, let us say the road is of 10 kilometers. Okay, so they are walking on a road which is of 10 kilometers. So A has completed the walking. Let us say A has completed the walking of 10 kilometers road in 2 hours, let us say, in 2 hours. And B has completed the same walking of 10 kilometers in 4 hours. Then who is having more power here?
Ma'am, A, ma'am.
A is having
More
more
power.
power. Why? Because he has completed the journey of 10 kilometers walking in only 2 hours. But B has taken 4 hours. So the comparisons, if you see, the A can do the work in very short span of time. Mean to say, he is able to walk very speed. How he is able to walk? He is able to walk very speedily. So here power is connected with speed. Here power
Speed.
is connected with speed. So power measures the speed of work done. Okay.
Yes, ma'am.
At what speed the work is done, that is what the power measures. So power measures the speed of work done. the speed of work done. Everybody will do work, isn't it? You do some work, I do some work. Okay, so for example, in a class of 30 children, if I ask them to write some one question, okay, if I have asked them to write down one question, all the 30 children will write in a class that same question, but few of the students will write the question in 10 minutes, few of them will write in 20 minutes, few of them will write in 30 minutes. So now, whose power is greater than? Whose power is greater? The child who has completed the question in least time. In the child who has written very speedily, okay, will be considered as that particular child is having more power. So here the power denotes the speed. Abhinash, mute yourself. Lasya, mute yourself. Okay, so here the power denotes with what speed or with how much speed the work is done. Okay, so now I have explained you the concept of power. So it is rate of doing work. Power can be defined as rate of doing work. Power measures the speed of work done. Okay, so by keeping these 2 points in your mind, each one of you should give me one example related to how the power measures the speed of work done. You have to give me one example. So I don't want examples from Vishnu because Vishnu already has said one example. Okay, now other children should try for the examples.
So ma'am, can I?
Ha, Abhinaya, please.
Ma'am, there is a game, ma'am, lemon and spoon.
Okay,
One girl is nominated by A and one girl is B.
okay,
One girl is moving fast, ma'am, in in 10 seconds, and one
Okay.
girl is moving slowly, ma'am. So in girl A is more power, ma'am. Have more
so
power.
girl A is having more power.
Power.
Why?
She's moving fast, ma'am.
She is moving
Fast.
very speedily.
Yeah,
Okay,
ma'am.
she's moving with a speed at a speed rate. Okay,
Yeah,
so
ma'am.
here power is measured with speed. With
Speed, ma'am.
what speed the work is done, in that way the power is measured, right? So
Yeah, ma'am.
Abhinash, you said you will give. Abhinash, you can give now. Bike race? Explain then, but your voice is little bit problem. I mean, like it was not clear. No, Abhinash, not yet. Please check your audio settings. Meanwhile, I'll ask some other children. Lasya, can you try?
Ma'am, he's using a technique to do that.
Vishnu?
Ma'am.
You are speaking something?
No, ma'am, I didn't speaking.
Okay. Lasya, can you try? Please unmute yourself and speak.
We must give an example.
You have to give me one example for power.
So basically in a running race, there's runner A and runner B, and the distance is same, and if runner A finishes the race faster and runner B finishes the race a bit slower, it means that runner A has a faster power than runner B.
Good. That's fine. Next, others who would like to give few examples, you can try examples. Two more examples I'll consider. Rishikesh, do you want to try? Rishikesh, respond.
Ma'am, can I?
Who is this?
Ma'am, Vishnu.
Vishnu has already given, so we will not give now chance for Vishnu. Rishikesh, respond.
Yes, ma'am.
Please. Give example.
Ma'am, can I?
Who is this?
Nishita.
Nishita, please give. Give, please. Please speak louder. Please speak louder. Nishita,
okay.
please speak louder.
Okay. There's two kids having a
remote control cars.
Your
Hit
voice
A.
is low. Your voice is low actually. Please a bit louder.
I am speaking.
Please.
Can I join again?
Yes, if you want, you can join again because your voice is not so much clearer. Okay. Right. So now I think everybody have understood what is meant by, power. So power measures the speed of work done, mean how fast the work is done or how slow the work is done. Okay, power can be defined as rate of doing work.
Work.
Okay, any work is there, the rate of doing work is called as power.
Power.
Okay, so this power, to write it in the form of expression, we will write like power is equal to work by time. I'll
W by
write
T.
1 minute. So note it down in your running notes. Okay, you write the heading power and you write you note it down. Power measures the speed of work done. The speed of work done, that is how fast or slow work is done. Next point, power is defined as,
Ma'am, can you repeat first one, ma'am?
yes,
Yes, ma'am.
power measures the speed of work done, comma, that is how fast or slow work is done. That is how fast or slow work is done. Okay,
Yes,
how
ma'am.
fast or slow work is done. Next point, power is defined as the rate of doing work. Rate of doing work. Now you note it down expression. Power is equal to work
J
by
T.
time. So power is denoted by letter P. Work is denoted by letter
J.
W, and then time is denoted by T. So P is equal to W by T is the formula for power. Okay, so units of power. Units
Watts.
of power. So the power is measured in what, children?
Watts.
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 Watts. Okay. So now, how this name watt has come? In the honor
By the
of
scientist.
Ma'am, scientist name, ma'am.
in the honor of James Watt. In the honor of James Watt, he is a scientist. Okay, he is a scientist who is there from 1736 to 1819. James Watt. So in the honor of his name, the unit of power is given as watt. Okay. So now 1 watt is equal to 1 watt
J
is
by T, ma'am. 1 J by 1 T.
1 joule. Okay, 1 watt is equal to 1 joule
1 joule of
per
work.
second.
Yes, ma'am.
1 watt is equal to 1 joule per second. So I can write why it is 1 joule per second, children. You can note it down. 1 watt. 1 watt is the power. 1 watt is the power of an object. 1 watt is the power of an object which does work at the rate of 1 joule per second, which does work at the rate of 1 joule per second. So I have written 1 watt is equal to 1 joule per second. So this can also be written like 1 watt means 1 W is equal to 1 joule means 1 J per second can be denoted as yes. Like this also it can be written, or 1 watt is equal to 1 joule per second. In this way also it can be written. Okay. So if larger amounts of energy, larger amounts of work is done, or if larger amounts of energy transfer is done, okay, if larger amounts of power is required, so what is the smallest unit of power? Okay, what is the smallest unit of power? For example, gram is the smallest unit of weight. Okay, gram, we have milligrams, we have grams, again we have kilograms. So kilogram is highest unit. So milligram is smallest unit. In the same way, watt is the smallest unit of power. And then what is the highest unit of power, children? Can anybody tell me? What is the highest unit of power?
Ma'am, kilowatt.
Yes. So 1 minute. So this watt is the smallest unit of power. And at the same time,
1 kilowatt is the highest, ma'am.
yeah, 1 kilowatt is the highest. So please note it down in your notes. These all information is important for your problems. So kilowatt. 1 kilowatt is equal to 1000 watts. Okay, 1 kilowatt is equal to 1000 watts. I can write this as kilowatt is denoted by kW is equal to 1000 W. Okay, and I can also write this as 1 kilowatt is equal to 1000 joules per second. Why I can write like this, children? Why I wrote joules per second?
Ma'am, because 1 watt is equals to 1 joule.
Yeah, here I have mentioned clearly like
ma'am.
watt is equal to 1
Because
second. So 1000 watts is equal to 1000 joules per second. Okay. Noted. I request all of you to please note it down.
yes, ma'am.
Okay. So now we have studied about what is power. So then what is average power, children? Because you know we have different examples where power is consumed in different ways at different intervals of time. For example, we have industries, we have lot of machineries. Okay, in the industries, few machineries they require lot of power, and few machineries they require less power. So if I want to calculate the total average power, so we have a new term called as average power. So what is average power now? Average power means if I want to calculate the power on an average, sometimes you know the machine requires lot of power in processing of some material, and sometimes the same machinery requires less power. Okay, for example, I am preparing some material, okay, in my industry, and the machine uses huge amount of power initially, and in middle it uses some less power, and again it uses high power, and again it uses less power. So in that way the power is fluctuating from high power to low power and from low power to high power. Then I have to count. If I want to calculate the total power, then I have to use, or I have to know what is the average power. concept of average power. So then average power means, average power is nothing but it is the total energy consumed, total energy consumed. It is calculated by dividing total energy consumed by total time taken. So average power can be calculated by dividing total energy consumed by total time taken. So you write it down in your notes. Average power, you put small side heading and you note it down. Average power can be calculated by dividing the total energy consumed by total time taken. Total energy consumed by total time taken. Okay, everybody had noted down?
Yes, ma'am.
Right. So now we let us understand what is the commercial unit of energy. See, we have some commercial and normal units are different from commercial units. Can you tell me what is meant by a commercial unit? See, 1 watt is equal to 1 joule. Okay, so 1 watt is equal to 1 joule per second. I told it as the unit for power. Okay, 1 watt is equal to 1 joule per second is the unit for power. It is a small unit. It is a very small unit. But in the industries, big industries, machineries will use lot of energy. Okay, so they want lot of energy and lot of energy is consumed. So 1 joule of energy is not sufficient for any machinery to run. So in such big industries, this unit joule or unit watt is too small. Okay, so when we want to express large quantities of energy, okay, so some bigger units of energy called kilowatt hour. So the bigger unit of energy. So you write down the heading. 1 minute. So you can write down the heading commercial unit of energy. Commercial unit of energy. Commercial unit of energy. Okay, so now you can write the bigger unit of energy, the bigger unit of energy. The bigger unit of energy called kilowatt hour. Kilowatt hour. It can be represented as kWh. Okay, is called as commercial unit of energy. Commercial unit of energy. Why is this commercial unit of energy is required, children? What is the use of this commercial unit?
Ma'am, can I?
Yes, Vishnu.
Ma'am, maximum of the many industries or the many factories or anything, mostly power is used, whether in watts, no, ma'am.
Huh.
Usually in a normal DC motor also they will measure the watt with 1500 watts, 1600 watts, 1000 watts. Like
So 1 watt is
industries
too
also
small.
this will be-
1 watt or 1
Yes,
joule
ma'am.
is too
Yes,
small
ma'am.
for a big machinery to work. So, and it is also inconvenient to express in units also. So what will happen? Larger quantities of energy, whenever the industries are using larger and larger quantities of energy, we want some bigger unit of energy. So the bigger unit of energy is called as kilowatt hour, which can be written as kWh. Okay, this is considered as commercial unit of energy. So let us simplify it. Okay, let us please note it down. Okay, so I told 1 kilowatt. 1 kilowatt hour is equal to, okay, 1 kilowatt hour can be written as 1 kilowatt into hour. Because what is the definition of watt? Or what is the definition of power? It is 1 watt is equal to 1 joule per second. So their time is there. Power is equal to work by time. Hence here 1 kilowatt hour. Hour means here time. So 1 kilowatt hour can be written as 1 kilowatt into 1 hour. So 1 kilowatt is equal to, I told already values. 1 kilowatt is equal to
1000 joules, ma'am.
1000
Second.
joules or 1000 watt. Okay, in the previous
1000 watts, ma'am.
you just refer 1 kilowatt is equal to 1000 watts. I have already
Watts.
told you
1000 watts.
1000 watts. 1 hour is equal to how many seconds, children?
60 seconds. 60
seconds.
minutes.
1 hour.
60 minutes.
Second,
36
you are
hundred.
talking about
3600 seconds.
you are
Yeah,
talking
3600.
about minutes. I am talking about seconds. So 1
Ma'am,
hour is equal
3000.
to
3600.
2600 or 3600 seconds.
Seconds.
So this, if it is simplified, it can be written like this. 36. How much, Nana? How many zeros will come? Here we have 3 zeros. There we
5
have
zeros,
2 zeros.
ma'am.
So 5 zeros we will have. And here joules. Okay. Now
Yeah, ma'am.
I can write like this. 1 kilowatt per hour is equal to, this can be written like 3.6 into 10 to the power of 6 joules. Okay. So now finally 1 kilowatt is equal to, if anybody asks you, this is the value which you need to by heart again. Okay, you have to remember in your mind. Okay, this value will be repeated when you do some problems. So this value you have to keep in your mind, you have to memorize it, you have to by heart it, and finally you have to remember it. So 1 kilowatt is equal, because this value will not change. Any problem, if it comes, the value of 1 kilowatt will be same throughout your life. So 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. So you have to by heart like this. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. So in this way you have to by heart. Okay. So now the same commercial unit. See, when we have electricity bills. Okay. So in electricity bills also we use electrical energy. So for our household works, okay, or for some commercial establishments like industries and other things. Okay. So this electrical energy, when we use, we will get electrical bill every month. Okay, this electrical bill is expressed in terms of units. Okay, every month we will get electricity bill, and this electricity bill is expressed in terms of units. So 1 unit is equal to Can anyone tell me what is the value of one
Ma'am,
unit?
1 kilowatt.
So
Ma'am, 1 kilowatt hour.
1 unit is equal to 1 kilowatt hour. Okay. So 1 unit is equal to 1 kilowatt hour. Generally, our electricity bills will come in the form of number of units consumed, mean number of kilowatts per hour consumed. Understood, children?
Yes, ma'am.
Yes, ma'am.
Anybody who did not understand today's concept? Huh, children? Anybody who have not understood? How can I define 1 kilowatt hour?
Sir, ma'am, 3.6 into 10 to the power of 6
That
joule.
is value, but definition you can note it down. The
Okay.
energy used in 1 hour, the energy used in 1 hour at the rate of 1 kilowatt, at the rate of 1 kilowatt, at the rate of 1 kilowatt is called as 1 kilowatt hour. Is called
Ma'am,
as 1
At the
kilowatt.
rate of
At the rate of 1 kilowatt, 1 kW.
okay, ma'am.
1 kilowatt is called as 1 kilowatt hour. 1 kWh. 1 kilowatt hour. 1 kWh. In brackets you can write. So is this concept clear for everybody, children, or anybody did not understand? Please raise your hands. We have discussed about power. We have discussed about the formula for power, definition of power, and then units of power, and then how the larger rates of energy transfer or larger rates of power consumption can be written like. And we have also studied about average power and what is the definition for average power. And then we have studied about commercial units of energy. And I have explained you what is meant by 1 kilowatt hour. The bigger unit of energy is called as 1 kilowatt hour. Okay, the value of 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules, which you need to by heart it. And then electrical energy is measured in units. So 1 unit is equal to 1 kilowatt hour. Okay, so this is all what I have explained today. If anybody have not understood, you can raise your hand or you can ask me now itself. I will repeat for you or I'll explain you once again if you have not understood. Everybody are clear with this?
Yes, ma'am.
Yes, from boys?
Yes, ma'am.
Is it clear for you all?
Yes, ma'am.
Any
Clear.
doubts you
Yes,
have?
ma'am.
Yes, ma'am. Clear.
Okay, so with this concept, we have completed this teaching part of work and energy chapter. Okay, we have completed the teaching part of work and energy chapter from physics. Okay, so actually for term one
Okay, ma'am.
examination, I am planning to give you 3 chapters from the physics. One is motion, second one is force and laws of motion, and third one is gravitation. And because few of the topics from chemistry will be added again, and few of the topics from biology will be added again. So again, the portion will be too big for you because these are only half yearly examinations, term 1 examinations, or otherwise we can call it as half yearly examinations, where half of the portion is advised to give. So in the entire science textbook, we will give around 60 to 70% of syllabus for term 1 examination, which will be a combination of biology, physics, as well as chemistry. So physical science, already whatever the chapters which I have completed theory part, mean explanation, and I have explained all the problems also, and I have given notes also for the chapters motion, force and laws of motion, and gravitation. So that 3 chapters, complete full chapters will come for your term 1 examination, which will be continued with some topics or some chapters of chemistry and some chapters of biology. So what
Ma'am,
are
can
all
you
the
repeat the
chapters?
chapters?
Yeah, from physics, motion, force and laws of motion, and gravitation. Total complete chapters. Okay, force and laws of motion, motion, as well as gravitation. These 3 chapters will be the syllabus for your term 1 examination. Okay, it is clear, I think so. So, and
Yes,
again,
ma'am.
work and energy,
Can you repeat again?
nothing, Nanna. Motion chapter from physics, motion.